Yes. Good morning, dear students. In yesterday class, we discussed about the harmonic oscillator. The harmonic oscillator, it means the one body is just oscillate with a constant frequency and constant amplitude. Or the harmonic oscillation is nothing but the oscillation of a body which expresses in terms of the single harmonic functions. Those single harmonic functions are nothing but the sine function or cos function. Sine function or the cos function. Yesterday I drawn one diagram also there. If it is the y-axis and this is the x-axis, along x-axis I will take here the time, the total time, and along y-axis it's displacement. It means displacement of the body. That is y is positive and it is the negative displacement of the body. When it starts from its mean position, call this position as a mean position, and that is origin. Okay. When it is just moving like this, okay, like this. Here it makes certain angle at here with the x-axis or with the time axis, or sometimes it taking with the y-axis also. Okay. If it is, the theta is an angle made by the body which starts to oscillate. The amplitude of the both waves should be same, and the frequency of the both waves should be same, or both waves should be same here. Up to here it completes one time period or one wavelength. Okay, then it is next, it is completely next started here. Okay. The maximum displacement of the body, the maximum displacement of the body is nothing but the amplitude here. Already written here. Amplitude is nothing but the maximum displacement of the body. And another one is theta is an angle, is a maximum displacement, the time taken by the body to oscillate for one revolution, that is nothing but the time period from its mean position to complete one revolution. It is nothing but the time period. And wavelength, that wavelength is also there. The wavelength is here, the wavelength is nothing but the distance between any two consecutive crests or any two consecutive troughs are there, or also the distance of one wave is also a wavelength. Okay, from its mean position. It is a mean position, the lambda is wavelength from here to complete one revolution. Here this is also the wavelength of that. Okay, it is the time period, this is the wavelength. Alright, one very important form here, just we have to remember always. Okay, the first one is if we want to take the time difference, path difference, and also the phase difference. Okay, if we want to phase difference here, the phase difference, one form, I write here one form. The phase difference divided by 2 pi, because for one revolution the angle should be 2 pi, or from here to here it is 2 pi. The phase difference is there, call this phase difference as a x or something, anything. I will take here x. X is a phase difference. It is not a displacement. It is not a displacement. It is only the phase difference. Okay. It is equals to path difference. Okay. Path difference. So if phase difference you can take here the phi. Okay. And the path difference you can take here x. It means take the total difference is there. That's why it is a delta phi. And it is called the delta x is a difference of a path, and divided by what is the total distance for one wave, that is lambda. Okay, it is lambda, or which is equals to the time difference. The time difference, call this is delta t divided by the total time taken for one revolution, that is t. We have to keep, or we have to remember always this one. This form is very important for the calculation of phase difference, path difference, and also the time difference. Okay, it is a very important thing. Okay, first we have to take here another one is what is mean by this angle theta. Here I mentioned theta, but here we are taking here that angular frequency, that is omega, and t, total time taken by the body. When it starts to oscillate, it makes a certain angle here, that this angle theta, this phase theta should be in terms of omega t. How it become? Omega is nothing but here the angular frequency or angular velocity is there. I'll write only just the for reference purpose here. According to the definition of angular velocity, it is nothing but the rate of change of angular displacement with respect to time here. Okay, angular displacement, call this is the theta. Angle is there when it is the continuously changing like this. Here the angle at the center is continuously changing. The angle is less, now it is more, then increasing. This angle is continuously increasing here. With respect to what? It takes certain time to change the angle. That is called what? The angular velocity. Okay, it is total angular displacement with the total time. Okay. Then we can write that theta is an angle, the angular displacement. It is equal to what? Omega t, where omega is nothing but what? The angular frequency. We can write that theta as a omega t. So that I will written that y is equals to a sin theta. What is mean by a? It is the maximum displacement. It is nothing but it acts as a resultant displacement of the body. If it is the A is the resultant displacement of the body, theta is an angle here along the y-axis. If it is y-axis, this is also considered as a y-axis. If it is a resultant displacement of the body, then here it is an opposite side. It is an opposite side of this right angle triangle. Opposite side takes here the sin theta with its resultant, that resultant considered as a if it is a sin theta, y displacement is equal to what happened? Y is nothing but what happened? A into sin theta. And x is nothing but its component, its another component, that is a cos theta. And theta is equal to omega t. Then you can write that sin omega t and also cos omega t. X as a cos omega t, y as a sin omega t. Okay? Yes. Now we have to take the single harmonic function. These harmonic functions are a sin omega t and cos omega t. Y displacement and x displacement of the body. This is a one form, very important form. Then some important definitions. We don't know what is mean by time period, what is mean by this wavelength, what is mean by the angular frequency, and what is mean by the frequency of the body. Linear frequency. Frequency is nothing but a linear frequency. The first one, some important definitions. First one is time period. It is denoted as the capital T, where T is the total time taken by the body, and T is the time period for one revolution or different more number of revolutions. Okay, T is there. T from its mean position to complete one revolution, that is called time period. Or if by our definition, according to us, the time period is nothing but the time taken by the body to complete one revolution is called a time period. Or it is after complete the one revolution, it starts to repeats its position also, repeats itself. If it starts from here, again here from it is considered as a mean position, one revolution is completed. After that it starts to repeat. It means what? It is the crest, trough, again crest, repeating. That is called what the repeating is there. The time interval for after which the oscillation of a body it repeats itself. Okay? Or the time interval, it is the smallest time interval. Okay? The time interval of a body after which the body repeats itself or it oscillates itself. Okay, yes, it repeats itself. It means what? The time period. Its SI unit. SI unit call this is as a time is nothing but the unit of the time is second. Here also the time period, its unit is second, denoted as small f. Okay, small s. Okay, the next thing is here. Another one is frequency. The frequency is nothing but very simple part. First, frequency is the reciprocal of time period, okay, or the number of oscillations made by the body per second, or the number of oscillatory motion, the number of revolutions of the body per second. Okay, frequency. Second one is frequency. It is denoted as nu or f, small f. First thing, its definition very simple. It is nothing but the number of oscillations. The number of oscillations or periodic motions, okay, because all oscillatory motions are periodic motions, na? So that oscillations made by the body per second. It means the number of revolutions. It means for 1 second, in 1 second, the how many revolutions are done by the body here. Only in one revolution, the number of revolutions made by the body. It means what? In per second. Per second is per 1 second is there. So that these are called the frequency of the body, or that frequency is denoted as here nu. It is nothing but what? The number of revolution. If it makes only one revolution, per second means per time period. Or also its definition is the reciprocal of time period is nothing but what? The frequency. Or it is nothing but 1 divided by t. 1 divided by t. It's SI unit. SI unit of the time period. So the frequency is here. The unit of time period is second. It is 1 by time period, that is nothing but per second. Per second, or it is also denoted as, or also mentioned as a hertz, denoted as Hz. Hertz is the unit of the frequency. Yes. Next is the angular frequency. Angular frequency already written one formula for that. That is the angular displacement with time. Okay, the angular displacement is denoted as omega. This is omega. This is called the angular displacement. Its definition is you can tell it is the rate of change of angular displacement with the time. Or another one is another definition. Very simple. It is the physical quantity. The physical quantity which is the product of the linear frequency with a factor, that factor is 2 pi. Here the 2 pi is nothing but the angle for one revolution. What is that? If it is 0, the omega t at the mean position is 0, and at here it become what? The maximum, that is pi by 2, it is 90, and here it is pi. For one revolution means it completes one circle. Okay, it is half and half. If it is combined together, then it becomes what? One revolution. That is nothing but here the 2 pi. Then what is the middle of these two? This is nothing but 3 pi by 2. 3 pi by 2. Okay, it means the 2 pi is the total angle. It means that theta is nothing but the total angle. Okay, it is the total angle for one revolution. Angular, it is nothing but what? It is a physical quantity which is the product of linear frequency. Linear frequency is already there. It is denoted as nu. And another one is f. Or it is f or nu is there. That this angular frequency is nothing but the product of linear frequency and the 2 pi. 2 pi is the angle for one revolution. This is the number of revolutions made by the body per second. And this is equal to omega is equal to 2 pi nu. One formula is ready. Another one is, or it is also right like this, because that nu is nothing but what? 1 by t. Nu is nothing but 1 divided by time period. If it is 1 divided by time period, then this omega become what? 2 pi divided by t. This is very, very important. This is only for one revolution. This is only for one revolution or one periodic motion. Okay, one periodic motion, it will become 2 pi divided by t for number of revolution. It means for n number of revolution, for n number of revolution or n number of periodic motion. What happens? That omega is equal to n is there, multiply by n 2 pi divided by t become what? 2n pi divided by t is the omega. Okay? Yes, it is. These are the some very, very important definitions about the oscillation, that harmonic oscillation. Last part of today. Today's last part is non-harmonic oscillation. The non-harmonic oscillation, it means what? Here it is expressed, the harmonic oscillation it is expressed in terms of a single harmonic function, and non-harmonic oscillation does not explain in terms of single harmonic oscillation. It means two or more than two harmonic functions are there. Non-harmonic oscillation. The harmonic oscillation, the oscillation of a body which does not express in terms of single harmonic motion. Okay, single harmonic function is also there. It means it is the oscillation of a body which cannot express in terms of single harmonic function. It contains the more than two or more than two single harmonic function. It means express in terms of two or more than two. If y is a displacement of the body, amplitude is there, that is, if it is a sine of theta is nothing but omega t plus another one is the b is a different amplitude. It means the amplitude is different here and it is cos of or sine of 2 omega t. If it is 1 omega t, then it is 2 omega t. It means the amplitude become the more here. The angle also just changing. It means what? This is the non-harmonic oscillation. There is no need to study about this one maximum. Okay. Yes. In next class, we have to discuss about the phase. Phase means the angle made by the wave, or the phase difference, the angle made by the angle difference between the two waves. Okay. Okay. Thank you.